In this video, we will not learn about a new programming syntax. We will learn about a programming trick that help you to do some nice coding to some of the problems. In this video and in many of the homework, we will focus on what we call a matrix, something that have all of the columns of the same number of columns, although it's important even for our case today. We might call it matrix, grid, 2D array, 2D lists, nested lists, and so on. The idea is as following. Sometimes in a matrix of 2D and you are at a specific position in the matrix, you would like to get the neighbors of your position. Sometimes you would like to get just the 4 neighbors like here, up and right and down and left, and sometimes you need to get the 8 neighbors around you. So the point is, many guys would do that through like 4 lines of code, 8 lines of code, which is a lot of coding. But we can, using a very simple loop of 8 steps, for example, and given some position ing, we can easily generate the 8 positions around us or the 4 positions around us. Here is a hint for you. Think in position like 0 and 0. What is its relationship between the 8 neighbors? So you might think on creating two lists. Each one of them is 1D, just one list of numbers that maintain this kind of relationships. So try to think about the difference between position 0 and 0 and the neighbor 8 positions. Okay, let me go ahead step with that. If we are at position in general row and C for row and the column, what is the relationship? What is the up? The up is row minus 1 and C. The right, for example, is the R and C plus 1. The diagonal here, the left diagonal, is R plus 1, C plus 1. So the question here about the difference between two positions. If we are at position R and C and we would like to go down, what happened? What happened that the row is incremented with 1, but the column is 0. No changes for it. So given the center here, I can get the down by just incrementing the row by 1. In a similar way, if we are at this position, I would like to go one step to the back. We don't need to change the row, but we need to decrease the C with minus 1. And so on. If we would like to move to the diagonal, we would like to add 1 to that and 1 to that. It seems given a position, we can easily use 2 arrays or 2 lists to maintain this minus 1 plus 1, 0 changes that might happen. We call that the direction array. Mainly in some of the programming competitions or like some context. So here is how to code it. Let's say that we would like to develop a function. Given that id and j, it will return for us the 4 neighbors of this position. We will create 2 lists here. List di or d row will maintain the 4 differences that we have if we would like to go down, right and up and left. And dj or d column will maintain the 4 differences that we need to move on the column. Specifically, or in other words, if you would like to move down, the row need to be increased with 1 and the column shouldn't be changed. If you would like to move right, the row shouldn't change, but the column should be changed. So you are here, moving here, the row doesn't change, but the column is increased with 1. If you would like to move left, it means that the row doesn't change, but the column will change with minus 1. Now given the ing, if we iterated with 4 iterations here over that, we can, given ing, generate using comprehension list all the next 4 positions that we have. I'm testing my functionality here, get neighbors of 0 and 0, it's returning for me all of these 4 positions, which as you see, some of them is out of the grid. On the other side, if I give like a 3 and 6, then I'm generating that going down would be 4 and 6, going right would be 3 and 7, and so on. I would like you to give a trial. Make a change for this function to return the 8 neighbors. So what are the other 4 values that we need here to maintain the 8 neighbors? Here is a bigger one. I'm extending it with a count up to 4 or 8 that do the same logic. Now here, if we asking for a get neighbors with 8, it provides us with the 8 neighbors around us. I don't want to get things more complex, but you can even, if you would like to get, for example, your neighbor after 4 steps in a specific direction, then you can multiply that with some factor, but forget about that for now. Maybe one change that you can think of it with yourself. This number sometimes might be out of the grid. So how can we change this function to filter out all of the positions that are out of the grid? Think about that. That's all.